So class 10, in this video we are going to discuss the very last topic from your optics or study of light portion of your syllabus, which is spectrum. So far, whenever we've used the word spectrum, what we've meant is visible spectrum. That is VIBGYOR, the 7 colors which we get when we pass white light through a prism. And we already know this phenomenon of splitting up of white light into its 7 constituent colors is what is called dispersion of light. And the band of 7 different colors is what is called the spectrum. More precisely, the visible spectrum. Now we've already learned that these 7 different colors, they travel with the same speed in air or vacuum. But inside any other medium, like for example inside the material of this prism, they travel with different speeds, and thereby the refractive index of the material of the prism is different for all these different colors, because of which they refract by different amount, or in other words, they split inside the prism. Not just that, we've also learned that for violet light the refractive index will be maximum, and for red light the refractive index of the prism will be the least. Thereby violet light, it refracts the most, and red light, it refracts the least. But this is all about visible spectrum, remember, because we actually need to talk about something called electromagnetic spectrum. And mind you, VIBGYOR, that is the visible spectrum, is only a very small part of this electromagnetic spectrum. So from now on, whenever you hear the word spectrum, you have to think of electromagnetic spectrum and not just the visible spectrum, remember. Now, this electromagnetic spectrum comprises of gamma radiations or gamma rays, X-rays, ultraviolet rays, of course our visible spectrum, VIBGYOR, infrared rays, microwaves, and radio waves. Since we know all rays are waves and all waves have wavelength and frequency. Now, all of these rays, they have different wavelengths, and what I've done here is I have arranged them in the increasing order of wavelength. That is, when we move towards the right hand side, the wavelength goes on increasing. Or if you wish to come from the left hand side, so this is in the order of increasing frequency or decreasing wavelength, so to say. Because mind you, frequency and wavelength are inversely related. Now your syllabus demands that you know at least 2 properties that are common to all of the electromagnetic radiations. I have listed 4 common properties here, some of which you already are familiar with, like all electromagnetic rays move with the speed 3 × 10⁸ meters per second in air or vacuum. Now, very often we've used that light travels with the speed 3 × 10⁸ meters per second in air or vacuum. So when we say light, we are referring to the visible part of the spectrum. But mind you, this speed in air or vacuum is common to all electromagnetic radiations. Also, all electromagnetic radiations, they do not need a material medium to travel, unlike sound waves. Number 3, all waves are transverse in nature. All electromagnetic radiations are transverse in nature, whereas we'll study about sound waves we'll see are longitudinal in nature. Also remember, all electromagnetic radiations are not deflected by electric or magnetic fields. Now, according to your syllabus, you also need to know 2 uses of infrared radiations as well as that of ultraviolet radiations. Now, the most common use of infrared radiation is in the remote control of a television. Now, we press the button of a remote control every day, and with every press what happens is infrared radiations are emitted from the remote control, which goes on to hit a sensor in the television, because of which the channel gets changed. But of course, we do not see infrared radiations getting emitted, because except for the visible spectrum, all electromagnetic radiations are invisible. Its other use is that infrared radiations are used in night vision cameras or heat sensing cameras. Remember, all hot bodies actually emit infrared radiations. Now, there are these special kind of cameras you must have seen in Discovery kind of channels also, Now these special cameras, what they do is they capture the infrared radiations that are emitted by all warm-blooded animals. And thereby a night vision camera or heat sensing cameras can track the movement of animals. Let us now finally look at the use of ultraviolet radiations. Ultraviolet radiations are used for sterilizing purposes, like instruments that are used in hospitals or could be in a lab. Likewise, ultraviolet radiations are also used for detecting the purity of gems, eggs, ghee, etc. Now, this second point especially I have simply copied from your book because I've never seen this happening. I'm only getting to know about this from your book. But please do remember two uses of ultraviolet radiations also. With this, we end the topic light. From next video onwards, we are going to talk about sound, a very, very important topic for you all.